This is Pasco Made Easy with Senana. And today we want to consider core mathematics. We are looking at how we can solve past questions for WASI. But remember that this implies that you can be able to learn things around topics for yourself, whether you are looking at different types of examinations, depending on what you are looking at in mathematics, right? So we are considering questions on sets. Remember that you like this video, share this video, subscribe to my YouTube channel and click on the notification bell so that you can get all videos on time. So set is something that we learn in mathematics where we see collection of items, right? How things are gathered or how things are collected and described. So we want to look at the question in WASI and how to solve it. And these questions are questions you can see in other areas, right? So let's look at the question. The question says that the set A, B, and C are defined as, so they've defined some sets for you and they've listed the members in all these sets, right? So in A, we see that there are members 1, 3, 5, 7, 9, 11, 13, and 15. B has members 9, 12, 15, and then we have C has members 5, 10, 15, and 20, and then 25. Now, A, we have to draw a Venn diagram to illustrate the above information. And then B, we have to find B intersection C. And then we are also to find A union B intersection C. And then we are also to find the number of elements in A union B. So let's consider how we can solve this question. So basically, with this, you don't need to write out the sets again, right? Writing out the sets will not give you any marks. All you need to do is to go straight forward and plot your Venn diagram or draw your Venn diagram. So let's draw a rectangular Venn diagram, which is easier to draw. It's something we are familiar with, right? So we can have a Venn diagram. Now, the sets described are both A, B, and C. So we can represent our A with our circle, right? And then we can represent our B with another circle. Now, when we consider A and B, realize that there are common elements in A and in B. So there is 3 in A, there is 3 in B, right? And then there is also 15 in A, there is 15 in B. So it means that there will be an intersection. So we can intersect the A and the B, right? So this can be our B, and then we can have our A here, right? And then let's look at C. So there's also something that is common to both A, B, and C, which is our 15. We see 15 in A, we see 15 in B, and then we see 15 in C. So we can have our C interlapping for 3 of them, right? So this is a set that has 3 of them interlapping together, right? So we now want to put in the elements in each place. So first we want to consider what is common to both A, B, and C. So we see that there is 15 in A, there is 15 in B, there is 15 in C, right? No other elements again exist in A, B, and C. So you can put a 15 at the intersection of the A, B, and C. Now let's consider A and B. What elements can we find in A that we can also find in B? So when we see A and B, 1 is in A, it's not in B, but 3 is in A and it's in B. So you can put 3 here. Let's consider 5. 5 is in A, it's not in B. 7 is in A, it's not in B. 9 is in A and it's in B. So 9 is here. And then we have 11 is in A, it's not in B. 12 is in B, it's not in A. 13 is in A, not in B. So that is it. Now let's also consider A intersection C, right? What elements can we find in A and we can find in C, right? So we can find 1 in A, we can find it in C. We can find 5 in A, we can find it in C. So we can put 5 here. And then we can find 7 in A, we can find it in C. We can find 9 in A, it is not in C. We can find 11 in A, it's not in C. Then we have 13, it's not in C. 15 is in C, but it's covered at where we have A intersection B intersection C, right? And then let's consider B intersection C. So when we look at B and C, we realize that there are no elements in B that we can also find in C. So we'll look at the only. So let's consider A only. So when we take 5, 15, 3, and 9 out, which ones are left that we can put in the A only? So there is 1 there, right? 3 is already covered, 5 is already covered, there is 7, right? 9 is already covered, there is 11, 13 It's not covered, so you can also put 13 there. So we have 1, we have 7, we have 11, then we have 15. And then when we consider the B, we already have 3, we have 9, we have 15. So what can we consider that we can put at B? There is 6, right? And then there is also 12. Now when we look at the C here, only here, what can we consider? We see that there's 5 and 15 already. So you can put 10, then we can put 20, then we can put 25. So once we are done, we put our union at the top. And then we've solved our first part. We've done our Venn diagram. Now let's consider the questions under the Venn diagram B. So we are asked to find B intersection C. Remember that the intersection is written without a 6. It's not an N, right? So it's B intersection C. So B intersection C, we are considering the members that belongs to B and at the same time belongs to C. So when we look at it very carefully, we see that they compose of all the members that are in this box here, right? So we are not considering only B intersection C only. So that will be the member 15, right? Then we can also consider the second question, where we are asked to find A union B, right, intersection C. So let's list A union B, which represents members that are in both A and B. So let me write my intersection well. I've seen that the intersection has a stick, right? So sometimes there's a tendency that you write the intersection and it looks like an N, right? You might not be penalized, but make sure you write it well. So A union B are all, let's list all the elements in A and B together. So we can begin from our 1, we have our 3, we have 5, we have 6 as well, we have 7, right? We have 9, and we have 11, we have 12, yes, we have 12, we have 13, and then we also have 15, right? So we have 15, right? So let me write the 6th one. Okay. Okay, so we have our 6, right? So that is it. So these are the elements in A union B, but we have to find A union B intersection C. So let's consider the C, and then we'll look at what is common to both A union B intersection C. So when we look at C could have 5, 15, 10, 20, and 25. So we can see that what is common to both of them is the 5 and then the 15. So we have 5 and then we have 15, which we see is common to both A union B and C, right? And then we have to list or find the number of elements. So this one we need to just count and write the number of elements. So let's count the number of elements in A union B. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So it means that we have 10 elements in A union B alone. So in this question, basically, we have considered a question on set where the question is asking us to draw a Venn diagram when the set has been described for us or listed for us. And then we use that to solve questions that are following.